Thank you very much for the opportunity to present the work that we're doing at the James Hutton Institute. We're really proud and excited to be presenting this work, and it's a great honor for us because this is an area that we are only just beginning our journey on, and we're really hopeful that in the years to come that we'll be able to add more and more value. But at this point, we're just really excited to show you the work that we are doing, and one of the first projects that we've been fortunate enough to be able to start in partnership with the James Hutton Institute. So the basis of the work that we're doing is centered around the capability that we have implemented at the James Hutton Institute, which is called the Future Farming Hub. This is an indoor growing facility built within shipping containers. It was built within shipping containers so that we could physically move the thing around. It was originally built in close to Sheffield and York, and then shipped up to the James Hutton Institute. And what we have in here is a research facility that allows for excellent control over the environmental conditions, including the lighting and the nutrient delivery capabilities, and 3 different growing capabilities. We have a nutrient film technique, we have an ebb and flood, and a deep water growing technique. And what the range of these capabilities of growing allows for us to do is to explore the value that commercially viable indoor growing technologies might offer the traditional growers or growers in the years to come. And in the very first instance, our first project, which we're really proud about, is working with Dr. Susan McCallum to look at germination of blueberries within this facility. And I'll talk a little bit about that work as we move forwards. Effectively, what we have within the Future Farming Hub facility is the ability to control, as you would within in many respects, as you would within a phytotron type capability, many aspects of the growing conditions that the plant are experiencing, from the control systems to the lighting to the nutrients to the hydroponic solutions. And the facility has capability and has many sensors and many sensing capabilities within it, which allows for us to offer the ability to monitor as the crops grow and to offer understanding about some of the effects that are happening within that. So we can utilize this tool both for research and also for the development of the capabilities as a whole. And strategically, what's important in terms of the technologies is that they are technologies that are commercially viable. So the lighting facility capabilities and the hydroponic and the control system capabilities are capabilities that could be scaled to a much larger commercial scale, should that be economically or useful or viable, or for whichever reason you might want to do that. And so it's a commercial demonstrator facility that isn't just a big phytotron. It shows what can be done in these kinds of facilities at a scale that is commercially relevant. And this very first project that we've been looking at is to understand what we can do with this facility for blueberries, and to see if we can speed up the germination time of those blueberries. And the projects with Dr. Susan McCallum at the James Hutton Institute, we looked at the snow chaser blueberry, and this is work that's really hot off the press. It's work that started in April, as I recall properly, and has happened throughout lockdown. And the work has happened here on site at the James Hutton Institute in these shipping containers, you can see. Fortunately, we're external of weather factors, and what we've been able to do is to implement the lighting control capabilities that we have and that we have access to, implementing with a nutrient film technique and controlling the pH between 5.8 and 6.2. And what we've shown is that we can reduce significantly the germination time of these blueberries from 10 weeks or thereabouts to 21 days. And for us, this was really exciting because it has potential commercial value within the facility as a technology. Of course, it can be useful in many respects to be able to reduce germination time of seedlings as they grow, and this is potentially a technology that we're going to look to explore and develop and understand the value in other crops as we move forwards. Of course, we're also really excited that the very first project that we've chosen to work on has produced such an interesting result for us. So where we think that the value of this product can offer the soft fruit industry as we move forwards is that as a growing capability, it is fully controllable. It does allow for speeding germination time. It also allows for speeding of speed breeding. You'll see from our lighting capabilities, as I've listed here, that we've got both a white spectrum light, which we use for early stage growth, but also we have full spectrum control over our LEDs, including the color and brightness, all the way up to over 1,000 micromoles per meter squared, which allows for us to grow crops all the way through to fruiting. And so the combinations of these things allow for the capability for speed breathing, and that's something that we're going to look to explore and develop over the coming years. We also recognize at this very first instance that indoor growing is not a cost-effective mechanism of growing full-scale commercial crops, but that it could provide a mechanism of improving the sustainability of growing in the future. As it is an indoor controlled environment, it can integrate with new energy management systems and renewable energy systems, and can potentially, with work and research, become a resource efficient and sustainable mechanism of growing produce. And this is something that is both dear to our hearts and also at the forefront of what we're trying to achieve with innovative produce. So in terms of what we're hoping to do in the future is, in partnership with the James Hutton Institute, become a leading indoor growing R&D developer, in particular, in this instance, looking at soft fruits and the capabilities within that, and also to understand what value we can offer speed breeding capabilities within this indoor growing system. And with that, I will wrap up my talk, and thank you very much for your time. Thank you.
Thanks very much, Dylan. And if any of those online at the moment have a question, would you be so kind as to type that into the Q&A function, which is on the right-hand side of your screen. You might have to click on the chevron and then simply start typing. The people who are the panelists should be able also to speak their question via the audio if they wish. I'll ask one to start with. Dylan, was this on your horizon when you started off your container-based facility at Hutton, or is this a project that has come to being just through on-site interactions with the people and the work that's going on here?
So this was not on our horizon right at the beginning. Right at the beginning, when we first envisaged the building of the facility, we were focusing around leafy greens, salad crops, and microgreens, where the majority of the industry exists in the indoor growing space. We of course were aware of soft fruits and the potential value that this kind of capability could offer, but it was it was further down our roadmap in terms of our thinking about when we might be able to achieve value in that space. And so it was only by working, understanding and talking to the researchers at the James Hutton that we identified that there could be this value. And in no small part, thanks to Susan's vision in this space, that actually the the value was shown to be there already.
And so from Susan's perspective, you say it's something that just kind of arose fairly spontaneously. And was this something that, without the facility that you have, particularly in your container-based lab there, is that not something that would have been possible in other circumstances, in other types of facilities? Is it a brand new thing as far as Susan's been able to develop as well? Maybe Susan can answer that one.
Yeah, I mean, certainly from my point of view, it's completely unique. I mean, this is something that the breeders, we've spoken about this before as a group, just how we can improve the breeding that we currently do and what we would need in order to be able to do that. And speed breeding is always something that's come up because everything that we do, it's always on an annual cycle. So the germination, we can only do it once a year. The crossing, we can only do it once a year. The early selection of the seedlings, we can only do it once a year. So to have a facility like Liberty's that allows us to go in and to look after the humidity and the temperature and to break that annual cycle has been fantastic. And the relationship that I've got now with Liberty, it came about through a different project. I was speaking to Liberty, we were trying to put in a completely different project on blueberries. But then we recognised that what we wanted to do in a different project, the project we were looking at was actually looking at mycorrhiza. And we've always been interested in how mycorrhiza can affect the blueberry plants and how it can speed up the establishment and help the plants to be healthier and established quicker. And we knew that the facilities that Liberty had could help us to control the environment and to give the mycorrhiza and the plants exactly what they were looking for in order to set up a control and look at how the mycorrhiza affect that. And it was only then actually getting into the facility and seeing what it can do, we started to think this is where we could, do the speed breeding. Potentially, if we can show that the germination rate could be quicker, if we can show that we can actually grow the seedlings in this container, then that gives us that foot on the ladder towards speed breeding. And Liberty have been so enthusiastic and so helpful to helping us set it up, and it's just been a great partnership, which hopefully will continue.
Where does it go next in terms of the next step in the process that you've started, or the relationship even that you've started? If you've
Yeah, I mean, in terms of the speed breeding, I mean, already, as Dylan has alluded to, I think they're certainly keen to now look at other fruit. We've shown that it works with concentrated blueberry. We have other breeding programs here, so I'm sure they would be very eager to get a foot into Liberty's door and try their crops. In terms of our future relationship, we're already in the process now of looking at additional funding that we can do with Liberty on a grander project. I can't go into too much details about that at the moment, but it's certainly something that we're hoping to apply for in the next month or so.
And Dylan, maybe it's a bit of a kind of a long look into the future. What's the kind of holy grail as far as you're concerned in terms of what you want your facility to be able to deliver?
Well, we're in terms of the day-to-day work that we're trying to do, we're looking at the capabilities of the technology in being able to supply value into the marketplace, and whether that's through breeding or speed breeding, or whether that's through providing a consistent quality of supply of crop, or enhancing certain attributes of that by being able to modify either the nutrients or some other aspect. What we're looking to do with this facility is just to show the value that can be obtained, and at the same time, we're working really, really hard to understand the mechanisms that we can improve the sustainability of growing within these kinds of environments, so that they become more and more commercially viable for more and more types of crops. At the moment, it makes sense it already makes sense for some of the microgreens to be grown in this area, but that's obviously a very small market. And what we're looking to do over the next 4, 5, 6 years is to improve the cost of the technology and also the sustainability of the technology to enable more and more crops. And if a vision for us in this regard might be to actually be able to grow some soft fruit all the way through to fruiting on a commercial scale. I'm sure in many aspects, in many areas of the world, that wouldn't work, but there will be some where this kind of capability does offer value in that respect.
Okay, any questions arising from any of the other panelists or any of the other attendees who are online at the moment? Louise?
Hi, sorry, I did try to put it in the question and answer box. It wouldn't let me submit for some reason.
You're a panelist, so you're only allowed to answer. You're not allowed to ask in the Q&A box.
That's fine, right? Okay, I just wondered. No, I just wondered in terms of and in the future for different projects. Basically, obviously.
Your mic's cutting in and out. You may have to lean forward a little.
Can you hear me a bit better now? Yeah. So in terms of future projects, obviously part of the breeding process is to determine which varieties are more susceptible or more resistant to pest and disease. And I just wondered, in going forward, what the capability of the kind of growing facilities will be maybe in the future. If there are plans to develop kind of more controlled environments that could possibly be used for infecting crops to maintain the kind of disease in a controlled environment. Is that something that would be possible for the future, or?
So, I mean, you'll have to bear with me because my biological understanding is fairly limited. I'm a physicist by training and an engineer by practice, but there are, as a basic premise, the ability to grow indoors offers control and security over many aspects of pathogens and other environmental effects, as well as pests that can affect some of these crops. And so, from a genetic perspective, the germplasm that's implemented to protect the crop from those environmental controls doesn't necessarily need to have quite the same effect in this indoor environment. And so, it's our belief, and we haven't proven this yet, but it's something we'd love to do, that there may be crops that are viable in this kind of environment that otherwise wouldn't be, that offer really interesting points of difference in flavour, whatever organoleptic aspect that you might look at, be it nutrient or flavour or something else as well. And so understanding that and going through the process of growing different genetic strains within this kind of facility, and then understanding that commercial value as well as the points of difference is something that we're super excited to try.